Okay then, so to celebrate finishing knowing the basics of the Mitchell-Benebow language, as in how to sort of derive all the rules and how it works and everything, let's talk about some more sort of, I'm going to talk in a very kind of loose way about some results without proofs at the moment, okay? Just to give a kind of flavour of the landscape. So this is a very nice connection, and I actually think it makes the Mitchell-Benebow language a lot easier to understand. So Mitchell-Benebow language can be called internal semantics because it's all sort of reasoning kind of internally about subobjects and so on, but there's also such a thing as external semantics, and that's basically saying, I mean, you know, in Mitchell-Benebow language you have these formula and you do extensions over them, and those are subobjects. Well, there's going to be certain arrows which are in those subobjects. Now, of course, we say if we have a mnemonic B and we have an arrow A, we say that A is in B when there exists a K such that A is B after K. All right. And so this is written A in B. So then this external semantics, also known as Kirpke-Joyal semantics, I'm not sure if I'm pronouncing that right, that's very useful, and we have a very concise description of it. So let me tell you. Let x bar be a list of variables x1, x2, blah blah blah, over objects a1, a2, blah blah blah. And let's suppose x bar contains all the variables that are free in phi. And let's suppose we have an arrow C, a general arrow C from a general object T into A1 times A2, blah, 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 all the way up to A times N. Now, we say that C satisfies phi if C is in the extension over the x's of phi. And basically, theorem 18.1 tells us when that happens. So let x bar list all the variables free in phi and psi, while theta may have a further free variable y of type B. Then for any arrow C into A1 times blah 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 all the way up to AN, we have the following results. C is in the extension of phi and psi. I'm extending over the x's unless I say otherwise. So C is in the extension of phi and psi if and only if C is in the extension of psi and C is in the extension of phi. C is in the extension of false if and only if this object where C comes from is initial. C is in the extension of phi implies psi if and only if for every arrow S into T, we have C after S is in the extension over phi, implies C after S is in the extension over psi. We have that C is going to be in phi or psi if and only if there exists an epoch S from some object zeta 1 plus zeta 2 to T, such that CSI1 is in the extension over phi and CSI2 is in the extension, is that the Miami one? CSI2 is in the extension over psi. And yeah, well, these I's are obviously the injections involved in this product here. Statement 5 is that C is in the extension of for all y theta if and only if for every arrow S, for every pair of arrows S and T from zeta, well, for every arrow S from zeta to T, and for every arrow R from zeta to B, we have that CS comma R is going to be in the extension of theta over the x's and the y. And finally, number 6, C is going to be in the extension of where exists y such that theta, if and only if there exists an epic S from some zeta to T, and there exists an arrow R from zeta to B such that CS comma R is in the extension of theta over the x's and the y. Okay, so that's really useful because we can use all those to really understand what these things mean. Now, another thing that's quite useful is being able to like talk about the specific arrows as if they're like pieces. So we know we have this monic, this diagonal arrow, 1a comma 1a from a to a times a, and we know its classifying arrow is called delta a. Now the transpose of delta a we're going to call curly brackets a, and when we do curly brackets a after an arrow x, we call that x in curly brackets. Now this is pretty cool because it basically gives us a way to say which arrows are in things. So the main result, I mean, remember this is, okay, so Goldblatt's definition of this kind of arrow I'm about to talk about doesn't have a twist in, but Colin McClarty's does. So in A, he defines as the pullback of true over E after this twist, P2, P1. Okay, and when we say X, H is in McClarty's in A, that we abbreviate that to say X McClarty in A H. Okay, so the result is that U is going to be McClarty in A curly brackets V if and only if U equals V. Okay, so we can see something about that in this diagram. But I mean, basically, I think what this is doing for example, well, when we feed in this arrow U, it's sort of, well, in this case V, it's sort of forming when we feed in something and do curly brackets on it, it's sort of forming the sub-object that just contains the stuff from that arrow. Yeah,